All right, guys, this is going to be our little practice problems for 10.2. I know there's a lot of questions on that one. There's 30 of them. They're kind of broken down. I did cover your notes, and I will be doing another video on talking about those notes and doing percent compositions, but that'll be coming up probably on Tuesday of next week. I'm not going to push you that fast, but let's look at these practice problems. The first 15 are one-step problems, which we did go over. And then the rest of those problems are multiple step until you get to the volume ones, which go back to being one-step one. If you've been working on them, you should have noticed that. If not, now you know. So I will also talk about the platinum problem that's in your notes. And I will also be coming back and working on that glucose problem, because it's a little bit different than some of the work that we've been doing on these worksheets. And I'll actually cover that as part of your notes before we do percent composition. So I do want you to try to work on that one in your notes, try to set it up and see how you do, because it's going to go from atoms to molecules, and then from molecules to grams. So it even has more steps than what we're doing today. So that is something to go back and look at and work on. But today, like I said, we'll do 10.2 practice problems. I picked out, I think, 4 total problems. Actually, more than that, to work on. I might only do a few of these. If you have questions, always email me. You can email me and say, hey, how do I do problem number, whatever. Get those to me, guys. So let's break this down. We'll do number 2. We'll start with number 2. Now, these do take a little bit more time. Remember, it's more important to show me your work, or to be able to do the work, than to get the answer. So hopefully you're not just going online, finding the answers, and just writing them down and thinking that's going to get it covered. It won't, because it's the process, just like this whole class has been about this whole year. So number 2, it wants to know how many moles of lead-2 sulfate are there in 158.1 grams of lead-2 sulfate, PbSO4. Okay, so we write that out just like we have in our problems before. Write out what we know. 158.1 grams of PbSO4 is equal to, question mark, moles of PbSO4. So to do this, that means we need to know what is the molar mass of PbSO4. We got to know what is its value. So we have to figure out the atomic mass units of PbSO4. So Pb weighs 207. Okay, and we're going to round that one down, AMU. Now, after last video, hopefully you will just say, oh, well, 1 AMU is equivalent to 1 gram per mole. So this now becomes 207 grams per mole. Okay. We also know that sulfur is equal to 32 AMU, but now I'm just going to do that in my head. That's going to be grams per mole. Oxygen is equal to 16 grams per mole, because it's 16 AMU. Again, 15.599 rounded up. Now, the other thing, remember, is that we have 4 of those. So we got to multiply that by 4, and that gets us 64 grams per mole. So we add all of those up, and we come to the conclusion that the total mass of this is 300 and I got to look at my notes, 3 grams per mole. Okay? And again, that's just from adding them up, right off our periodic table. There's no secret numbers coming from somewhere else. Okay? So that means that I can rewrite this as an equality. I can say, okay, I can break this derived unit, because it's made up of 2 parts, into 2 single parts. And we can say that 1 mole of PbSO4 is equal to 303 grams of PbSO4. Let's get a little line in there so those are separated. That's my equality. We all know once we get an equality, we can do conversions. So I take my 158.1 grams of PbSO4, make my conversion. I need to write everything out. Grams, need to get rid of those, so the 303 goes on the bottom. My 1 mole of PbSO4 goes on the top. Grams cancel out. I have 4 sig figs in my value that was measured, so my answer has to have 4 sig figs. So this comes out to be 0.52178, and I always go an extra space. If I have to have 4, I go out to 5. I see if that number is 5 or greater, then it's going to raise that one up. And I get an answer of 0.5218 moles of PbSO4. And again, I keep running out of room on my tiny little thing. So that's how you do problem number 2. Okay? Some of this you're going to start streamlining as you work through these problems. The more you work through it, the faster the streamline is going to go. If you're not, you have to set this up every time to see where your values are coming from. Let's look at number 12. Okay? Again, if you need to rewind this, rewind it and go over it again. Okay. Let's do number 12. This is another one-step problem. Now, they use the term formula unit. Don't get panicky about formula unit. When we talked about particles, this is the same thing called a compound because they're ionic. So your textbook and the textbook's really bad about misusing formula units too. So we can shorten formula units up to units, and you'll notice that most of the time they use it, it's for an ionic compound. So for number 12, and I'm going to do this one a little bit more streamlining, it wants to know if we have 5.38 times 10 to the 24 formula units, and I'm just going to write just units. I can shorten that up to units of MgBr2 is going to be equal to how many moles of MgBr2. Now this one's really nice because we don't even have to figure out atomic mass units on this one, because we know when we look at our notes that the equivalency that we use here is Avogadro's number. So 1 mole of MgBr2 will always be equal to 6.02 times 10 to the 23rd units. Again, notice I use the word units. I can change that to whatever else I need depending upon what they're asking for. Units of MgBr2. Okay, so if I have my equality, I can now do my conversion. This is also where knowing how to use your exponential function on that calculator is going to pay off. If you forget how to use that, you'll have to go back and do some practice problems from beginning of the year. Go back and look at your notes. Units, yes, you got to write everything out, folks. Okay, I'm going to do my conversion factor. It has to be nice and big because I know I have to write a lot of numbers in here. If units are on the top, this is 6.02 times 10 to the 23rd units of MgBr2 is 1 mole of MgBr2. Units cancel out. Bingo bango. I plug this in with my calculator, use my exponent function, and you come up with an answer of, and we look at right here, 1, 2, 3 sig figs. You should get an answer of 8.94 times 10 to the, times 10 to the anything, is 8.94 moles of MgBr2. Okay? That is number 12. Okay? Now, up to number 15, they're all single-step problems like this. Once you get to number 16 through 22, they're all going to be two-step problems. Okay, and we'll do a couple of those now. Okay, so again, you can rewind this, units, review the little video. Okay, let's look at some two-step problems now from 10-2. Let's look at number 20. Okay, number 20 wants to know